Welcome to our final lesson in this module on Java control flow constructs, which does not introduce a new control flow construct, but instead discusses a Java class that's most useful when we have the ability to use it inside a loop. That class is called random, and instances of it can be used to generate a stream of random numbers. After completing this lesson, you will understand the concept of random numbers and appreciate their importance in the field of computing. You will also know how to declare an instance of the Java random class and be familiar with the methods that you can call on that object. Finally, you will recognize how random numbers can be used in simulations and in other common computational apps. In this lesson, we're going to learn about Java's random class. But before we do so, let's discuss why we need random numbers in the first place. Computers have changed many areas of society because they can process so much data very quickly. But even more than that, they can also generate a lot of data very quickly. This data generation is usually required to be random, since the process we are attempting to simulate is itself random. Now, sometimes mathematicians and statisticians are able to come up with the answers we are looking for, but often the problem is too complicated to be modeled by a single formula, and thus a computer simulation is the next best thing. In fact, such simulations are so important that they have been given their own name, Monte Carlo methods. Such problem-solving strategies rely upon the generation of random data to compute their results, and are used to simulate all types of systems in business and science. We will not talk any more about Monte Carlo methods here, but Wikipedia has a long list of applications for the interested student. To support the generation of random numbers, Java has the random class. This class will allow us to generate what is known as pseudo-random numbers. That just means they are not truly random, but they appear random enough for all practical purposes. The random class has many methods, but the more common ones are listed here. They are nextInt, which returns a random integer, nextInt, which takes an integer parameter, which we call max, and which returns a random integer from 0 up to but not including max, and finally the method nextDouble, which returns a random floating point value from 0 up to but not including 1. The random class is a part of the Java util package, and so if we want to use it, we must have an import java.util.random statement at the top of our Java file. Then later in our code, we can create a random object by saying new random and assign it to a variable of type random. And at that point, we can then invoke class methods on the object. Here are some common applications of a random number generator. To generate a random integer in the range 1 to n, you would use nextInt method and provide n as a parameter. This returns an integer in the range 0 to n minus 1. And so you simply have to add 1 to that value to shift it up. Or to generate a random integer in any given range, you can use the nextInt method and use the size of the range as the parameter. That value then just needs to be shifted by the lower bound of the range. For example, to generate a value in the range 41 to 45, we use nextInt 5 and then add 41 to the result. You can also use random numbers in text processing. For example, we can generate a random lowercase letter, or we can pick a random letter from a string, such as picking a random DNA nucleobase from a string containing all possible bases. The nextDouble method returns a floating point value in the range 0 up to, but not including 1. You can create a random floating point value in any range of numbers by multiplying the result of nextDouble by the size of the range, and then shifting that result by the lower bound of the range. And any random process which has a finite set of outcomes can be simulated by mapping the possible outcomes to the integers. For example, to flip a coin, we can generate a random 0 or 1. To play rock, paper, scissors, we can generate a random 0, 1, or 2. Here's a simple example of using random numbers. Say we want to simulate the rolling of 2 dice until a double is rolled. We roll the 2 dice and report their values until they have the same value. In this example, we finally rolled a double 3 and then stopped. And here is the code to run the simulation. We first create a random object, and we declare a cumulative sum variable to keep track of the number of rolls. Then, in a do-while loop, we get a random number in the range 1 to 6 for each die and print out their values. We also increment our variable that is keeping track of our number of rolls, and we keep doing this while the two die are different. When we finally roll a double and both die have the same value, we exit the loop and print the final message. This lesson gave you an overview of Java's random class. Now that you've completed this lesson, you should understand the importance of random numbers and know how to declare an instance of the random class. You should also be familiar with the methods of the random class and be able to identify what they do. Finally, you should recognize how random numbers are used in simulations and other common computational apps.